Domain and range of function. Under functions basics, we saw the difference between a relation and a function. In either case, we are dealing with relationships expressed as ordered pairs. All of the values that can go into relation or function are called the domain. And all of the values that come out of a relation or function are called the range. Range may also be referred to as image. Note that both relations and functions have domains and ranges. Domain. The domain of a function is the complete set of possible values of the independent variable. The domain of a function f of x is the set of all values for which the function is defined. The domain is the set of all first elements of the ordered pairs or x coordinates. Remember, the domain is the set of all possible x values which will make the function work and will output real y values. How to find the domain? We determine the domain of each function by looking for those values of the independent variable, usually x, which we are allowed to use. Usually, we have to avoid 0 on the bottom of a fraction or negative values under the square root sign. When finding the domain, remember, the denominator or bottom of a fraction cannot be 0. The number under a square root sign must be positive in this section. Range. The range of a function is the complete set of all possible resulting values of the dependent variable y, usually after we have substituted the domain. The range is the set of all y or output values. We may describe it as the collection of the second values in the ordered pairs. The range is the set of all second elements of ordered pairs or y coordinates. How to find the range? The range of a function is the spread of possible y values, minimum y value to maximum y value. Substitute different x values into the expression for y to see what is happening. Make sure you look for minimum and maximum values of y. Example number 1. State the domain and range of the following relation: hair colors, teacher's name. A is equal to the set of Black and Ellie, Blonde and Sheila, Ash Gray and Diane, Black and Adrian. The domain of this relation is the set of Black, Blonde, Ash Gray. And the range of this relation is the set of Ellie, Sheila, Diane, Adrian. Is this relation is a function? This relation is not a function because the hair colors are repeated. Example number 2. State the domain and range of the following relation. A is equal to the set of 3 and -1, 2 and 1, 0 and 4, -1 and 6, -4 and 8. The domain of this relation is the set of 3, 2, 0, -1, and -4. And the range of this relation is the set of -1, 1, 4, 6, and 8. Is this relation is a function? This relation is a function because each value of x corresponds with exactly one value of variable y. Example number 3. Consider the relation f is equal to the set of 0 and 2, 0 and 1, 1 and 2, 1 and 1, 1 and 3, 2 and 5. Here, the relation is given as a set of ordered pairs. The domain is the set of 0, 1, and 2. And the range is the set of 2, 1, 3, and 5. Is this relation is a function? The domain elements 0 and 1 are associated with more than one elements, so this is not a function. Example number 4. State the appropriate domain and range of the given function. Y is equal to 3x plus 2. The domain of this function is the set of all real numbers, and the range of this function is the set of all real numbers. Example number 5. State the appropriate domain and range of the given function. F of x is equal to x squared minus 3. The domain of this function is the set of all real numbers, and the range of this function is the set of f of x is greater than or equal to negative 3. Why? Because here's the graph of the function f of x is equal to x squared minus 3. The graph forms a parabola that opens upward. It indicates the graph continues up the visible grid. So, assume that all real numbers are involved. To check if the graph is a function, we use a vertical line test. Since there is a one point of intersection, this relation is a function since it passes the vertical line test for function. Note, graphs that are composed of a connected curve are referred to as continuous graphs. A continuous domain is a set of input values that consists of all numbers in an interval. Example number 6. Here is the graph of f of x is equal to square root of x plus 4. The domain of this function is the set of x is greater than or equal to negative 4. Since x cannot be less than negative 4, to see why, try out some numbers less than negative 4, like negative 5 or negative 8, and some numbers more than negative 4, like negative 3 and 8 in your calculator. The only ones that work and give us an answer are greater than or equal to negative 4. This will make the number under the square root positive. And to find the range, we notice the curve is either on or above the horizontal axis. No matter what value of x we try, we will always get a zero or positive value of y. We say the range in this case is the set of f of x is greater than or equal 0. Example number 7. The function f of x is equal to 1 over x plus 2. It is not defined for x is equal to negative 2. As this value will result in division by 0, there will be a 0 on the bottom of the fraction. Hence, the domain is the set of all real numbers except negative 2. And to get the value of range, again, using the function of f of x is equal to 1 over x plus 2, no matter how large or small x becomes, f of x will never be equal to 0. Why? If we try to solve the equation f of x is equal to 1 over x plus 2 for 0, this is what happens. 0 is equal to 1 over x plus 2. Then, multiply both sides by x plus 2, and we get 0 is equal to 1. This is impossible. So the range of f of x is the set of all real numbers except 0. Therefore, as we can see in the graph of the equation f of x is equal to 1 over x plus 2, that the function is not defined for x is equal to negative 2, and the function y values takes all values except 0. And that's all for dominant range of functions. Thank you for watching. See you next time.